Hello everyone. Assalamu alaikum. This is MD Jahangir Hossain from MDH Math Assist. Today we are going to solve mechanic paper from Cambridge International AS and A-level from October number 23, variant 41. Okay, so without any further delay, let's get to the question. Okay, this is the paper from October number 23. Variant 41, paper 4, mechanics. Okay, without any further delay, let's get into the question number 1. In question 1, it says a particle of mass 1.6 kg is projected uh, with a speed of centimeter per second up a line of slope of a smooth plane inclined at alpha to the horizontal, where tan alpha is equal to 3 by 4. Use an energy method Use an energy method to find the distance the particle moves off the plane before coming to instantaneous rest. So, to visualize this sum, let's present it on a rough diagram. The horizontal is the inclined plane, and we have projected the particle with a speed of centimeter per second up the plane. Okay? You have to find. Let's say it travels a distance of x meter before coming to instantaneous rest. So here the distance is x meter. Okay. So what is happening here? The surface is smooth, so there is no work against friction. So it is losing its velocity coming to rest. So loss in kinetic energy. It is gaining height. So there is gain in GP. So these are the two things, and there is no external force. So no work done by external force. First of all, you see, we don't have the value of tan alpha, rather, we don't know the value of alpha, rather, we have the value of tan alpha. So, why don't we calculate the exact value of sin alpha? First, to calculate the exact value of sin alpha, let's consider a right angle triangle where opposite is 3, adjacent is 4, so that tan alpha is 3 by 4. Acute angle is the alpha. So if you use the Pythagoras theorem, find the hypotenuse, which will be 5. So sin alpha is 3 by 5. Now, if you calculate the KE loss, KE loss is half into M, U square minus B square. B is obviously 0. Half into M is 1.6, U is 20, is 0. And if you consider the GP, then since it is an inclined plane, you can calculate the GP gain by simply considering the component void along the plane into the distance it travels along the plane. So that is mg sin alpha into x. M is 1.6, g is 10, so that is 16 sin alpha into x. And you know the value of sin alpha, which is 3 by 5. So 16 into 3 by 5, that's 9.6. Now, if we consider the changes in energy, remember the original formula, work by external force plus loss equal to gain plus work against resistance. We do not have any external force here, so work by external force is 0. There is no resistance, so work by against resistance is 0. We have the K loss and Gp gain. K loss is 0.8 into 20 square. Gp gain is 9.6 x. So x is that is, if you calculate this one, you will have x equal to 100 by 3 meters. Okay, that's the value. That's the distance the particle moves off the plane before coming to instantaneous rest. That's question 1. Now let's move on to the next question. Next part is we have the next question 2. And question 2 is a particle of mass 2.4 kg is held in equilibrium by two light inextensible strings. You see the word two light inextensible strings, so the tension in each string will be different. One of which is attached to point A, the other attached to point B. The string makes angles of 35 degree and 40 degree with the horizontal shown in the diagram. Find the tension in each of the two strings. Okay, now let's see what are the forces acting on the particle here. There are tension coming from the string B is and this string, let's call it TA, and there is weight. These are the three forces acting on the particle. And remember to weight mass into G. So G is 10, so weight is here 2.4 into 10 is 24 meters. Now, we have two unknown forces here. To find the unknown forces, why don't we consider the two axes, one of the axes being the horizontal, the other one vertical. Okay? So in that case, you don't need to resolve 24 newtons since it is vertical, so you need to resolve the two tension. The component of tension B is TB horizontally cos 40 and vertically TB sine 40. That's upward. And component of tension A is TA cos 35 horizontal and TA sine 35 vertical. So if you equate these two, we have horizontally TB cos 40 equal to TA cos 35. So TB TA cos 35 by cos 40. And if you equate vertically, we have TA sin 35 cos TB sin 40 equal to 24. So if we substitute TB in terms of TA here, we have TA sin 35 plus TA cos 35 divided by cos 40 into sin 40 equal to 24. So TA will be equal to 24 divided by sin 35 plus cos 35 into sin 40 divided by cos 40. And this will give you the answer. The value of TA equal to 19.0. Then dB will be TA 19.0 cos 35 divided by cos 40, which is equal to 20.4. Both answer correct to DSF. Okay, that part 2 where we found the two tension in each of the two strings. Now let's move on to the next question. Question 3. In question 3, we see the diagram shows the velocity time graph for the motion of the ball. The ball starts from rest and accelerates uniformly for 8 seconds until it reaches a speed of 12.6 meters per second. The ball maintains this speed for 40 seconds. It then decelerates uniformly in two stages. Between 48 and 62 seconds, the ball decelerates at a meter per second square, and between 62 and 70 seconds, it decelerates at to a meter per 10 square until coming to this. Find the distance traveled by the bus in the first 8 seconds. In part A, we need to find the distance traveled the first 8 seconds, and this distance is the equal to this area. Remember, thanks to this velocity time graph, the displacement or distance will be the area under the graph. The distance traveled in the first 60 seconds is the area of the triangle, which is half into base into height, 12.6, which is equal to 80.4 meter. Then in the next part, you have to find the value of A. To find the value of A, see, from this one, 48 second, the velocity at 48 second velocity, 12.6 meter per second, at 70 second velocity is 0. And here the velocity decreases in 2 steps. Here the gradient acceleration the first segment is minus a, and the second segment acceleration is minus twice this deceleration. So if we apply this both deceleration together, v equal to u plus a1 t1 plus a2 t2, we have v equal to v0, u is 12.6 plus a minus a, that's minus a, into the time interval is 62 minus 48 plus a, this is minus twice a, the time interval 70 minus 62, 0, 12.6 minus 14a minus that is 16a. So a is equal to 12.6 divided by 30, that's 0.42. You might wonder why I'm directly applying this one. If you want to do it, if you don't want to follow this one, you can do it from 48 to 62 seconds. We apply v equal to u plus at, we'll have 12.6 minus a into 14, then 62, this is 12.6 minus 14a, and then 62 to 70 seconds. If you apply again v equal to u plus 80, v is 0, u is the velocity at t equal to 62, that is the velocity at t equal to 62, 12.6 minus 14a, and here acceleration is minus twice a into time is 8, so you have the same equation here, and you also get the value of a equals to 0.42 here. Same thing, so you can do it directly. You can consider the two decrease in velocity together, or you can do the consider the two time zones separately and apply v equal to u plus 80. Two time segment, not time zone, 48 to 68, this segment, and 62 to 70, this segment. Okay, that's part B where we find the value of A. Now, in part C, you have to find the average speed of the bus for the whole journey. To find the average speed, you need to find the total distance first. The total distance is equal to the distance, equal to the area under the graph. We already know the distance traveled in the first 8 seconds. Then this the second segment, it will be 12.6 into this time, that is 48 minus 8, because it's a rectangle. And then the third segment, we have the trapezium. For the trapezium, the value of v here is 12, that is 12.6 minus 14 into a, so it's 12.6 minus 14 into 0.42 is equal to 6.72. So We have a trapezium here, half into a plus b into 8. A is, and this area is equal to this area half into 12.6 plus 6.72 into 8. This is 13, and here we have a triangle. Triangle is half into 8 into 6.72. You add this total distance of each segment is time segment, then we'll get the total distance traveled. So it is in the first 8 second distance travel is 50.4. The next 40 second 40 into 12.6, and the next 14 second half into 12.6 plus 6.72 into 14 plus half into 6.72 into 8. That will give you the total distance, which is equal to total distance being, we have to add this 50.4 plus 40 into 12.6 plus 7 into 12.6 plus 6.72 6.72 plus 4 into 6.7. That is 716.52. So total average speed. Remember, average speed is total distance traveled by total time. Total distance traveled is 716.52. The total time. This means the total time is 70. So that is 10.70 is 10.236. That's the average speed. That is okay. That's part three of this question three. Now let's move on to the next question, question four. And question four, you see, we have two particles P and Q of mass 6 kg and 2 kg respectively lie at rest 12.5 meter apart on a rough horizontal plane. Coefficient of friction between each particle and the plane is 0.4. Particle is P is projected towards Q with speed 20 meter per second. You need to show that the speed of P immediately before the collision is with Q is 10 root 3 meter per second. Now, to find the collision, the speed just before the collision, you need to find the deceleration first. And how much is the rate of deceleration? To find it, if it moves forward, there will be friction acting on it, and friction is equal to mu r. R is here, mass mg. So R equal to mg, friction equal to mu r, that is 0.4 mg. Now it is moving forward direction in the forward direction. So if we apply the Newton's second law, you have minus friction equal to ma. So a is minus 0.4 into g, that's minus 4 meter per second square. So it is decelerating, and the initial speed 20 meter per second, distance it travels 12.5. So if we apply v square equal to u square, since we know initial velocity, we know the distance traveled, we know the acceleration, we need to find v. So involving this four, the equation is v square equal to u square plus 2a. So this will be 20 square plus 3 into minus 4 into A, 12.5. So V square is 300, so root over 300, that is 10 root 3 meter per second. So that is the step before the collision between the two particles. Now let's move on to the next part. In the collision, P and Q pulleys to form a particle and the loss of kinetic energy due to the collision. Remember, just before the collision, speed of P is 10 root 3 meter per second. After the collision, they move together. This is before collision, P and Q. Q is at rest. Q is moving with 10 root 3 meter per second speed. Mass of P is 6 kg. Q, mass of Q, 3 kg. After collision, they collides to form a single particle R. So mass will be combined mass 6 plus 2, 8 kg. And this speed is unknown V. So let's find the V first, then we'll calculate the loss of kinetic energy. So if you can apply the conservative law of momentum, sum of momentum before collision, remember, right, initial direction of motion to be positive, 6 into 10 root 3 equal to 8 V. So V is 15 root 3 by 2 meter per second. The loss in KE of the system, initial KE minus final KE. And initial kinetic energy is half into 6. We have two particles, so you have to combine the two. Half into 6 into 10 root 3 square plus half into 2 into 0 square. Although we are combining the kinetic energy of these two, but the kinetic energy of Q is 0 since it is at rest just before the collision. And finally, they combine pulleys to form a single particle. So kinetic energy half into 8 into V square. V is to combine the 15 root 3 by 2 square. So that will give you the loss in kinetic energy, which is 225 joules. That's the loss of kinetic energy due to the collision. That's part B. Then we have another part, part C. The coefficient of friction between R and the particle is also 0.4. Find the distance traveled by the particle R before coming to rest. So what will be the since what will be the deceleration here? Since value of mu is same and the surface is horizontal, so acceleration remains same. The acceleration, whatever the acceleration was between P and BT for P, the same acceleration will be for R. So acceleration remains unchanged. Why? Because coefficient of friction is unchanged. And apart from the friction, there is no other forces. So acceleration remains unchanged. Now we know the initial velocity, that's the velocity just after the collision, which is 15 root 3 by 2 meter per second. Final velocity is 0, so you have to find the distance and involving this 4 parameter. The equation is V square equal to U square plus 2 is V0 is 15 root 3 by 2 square plus 2 into minus 4 into S. So S, the distance we traveled before coming to this is 21.1 something something. If you correct it to one decimal places, the effect of one decimal place is 21.1 meter. Okay, that's part C. Is there any further part to this question? No. Let's move on to the next question then. In the next question, we have a sum involving pulley. The diagram shows particle A of mass 1.2 kg which lies on a plane inclined at an angle of 40 degrees to the horizontal, and particle P of mass 1.6 kg, which lies on a plane inclined at an angle 50 degrees to the horizontal. The particles are connected by a light inextensible string, which passes over a small smooth pulley. P fixed at the top of the plane, with pairs AP and BP of the string are taut and parallel to the line of critical slope. The two planes are rough. Both planes are rough with the same coefficient friction mu between the particles and the plane. Find the value of mu for which the system is in limiting equilibrium. Since the system is under limiting equilibrium, so acceleration zero. But the thing is, which particle is about to descend and which particle is about to ascend. To figure it out, you see the component of weight along the intended direction of motion of both particles. If you compare these two, you can easily determine which particle will descend. And component of weight along the intended direction of motion for A is 1.2 into Z into sine 40, that's 12 sine 40. And for B, it is 16 sine 50. Obviously, 16 sine 50 is greater than 12 sine 40. So B is about to move down the plane. It is important to determine the intended direction of intended motion, because only then we can figure out the direction of friction. So for B, friction will be upward of the plane, and for A, friction will be down the plane. Friction for B will be down the plane. So, friction for A will be down the plane. And the normal direction on B is equal to the normal component of weight, which is 16 cos 50, and normal direction on A is equal to 12 cos 40. And apart from these forces, there is also tension on the cable from the string acting on the two particles. Okay. Now, what particle is at is limiting equilibrium. So, for it can apply to equate the forces for B. First, R B equal to 16 cos 50, considering the normal forces in the normal to the plane. We consider forces along the plane, then we have T plus FB equal to 16 sine 50. The T is FB, 16 sine 50 minus FB. FB equal to mu into RB. So 16 sine 50 minus mu into RB, which will be 16 mu cos 50. Okay. Now for A, the normal forces, normal to the plane, A equal to 12 cos 40, and along the plane, upward is T, downward is 12 sine 40 plus friction A. So it is 12 sine 40 to plus mu into RA, is equal to 12 sine 40 mu So RA is 12 cos 30, so 12 means cos 30. Now, both tension are equal because the string is light and the pulley moves. So, we get both T, we have 12 sin 30 plus 12 mu cos 30 equal to 16 sin 50 minus 16 mu cos 50. The value of mu is equal to 0.2 to correct to the estimate. Okay, that's question number 5. Let's move on to the next question then. Is there any further part to this question? No. So, next question is question 6. And question 6, let's see, a car of mass 1300 kg is moving on a straight road. On a horizontal section of the road, the car has a constant speed. So there is a constant force of 650 Newton resistance to motion. So the horizontal road, it is moving with constant speed, the acceleration 0. Forward driving force should equate the resistance. So that acceleration 0. And remember, forward driving force is equal to P, power forwarded by the engine, by the speed v. So we have P by V equal to R. So P equal to R into V. R is here 650 and V is 30, which gives the power, and you have to give it correct to, you have to give it in kilowatts, and it is 19,500 watt. So in kilowatt, it is 19.5 kilowatt. That's the power developed by the engine of the car while this car is moving at constant speed along this horizontal road. Given that this power is suddenly increased by 9 kilowatt and the instantaneous acceleration of the car. So when the power increased by 9 kilowatt, so driving force further increases. When the speed is 30 meter per second, power is 19.5 kilowatt, but it is suddenly increased by 9 kilowatt, then you have to find the instantaneous acceleration. In that case, uh, since it will accelerate, so driving force minus resistance equal to ma, and driving force is original uh, power was 19.5 plus increase 9 into 1000 divided by V 30 minus resistance 650 equal to ma. Mass of the car is 1300 to A. So it is 3000 divided by 30 minus 650 divided by 1300. So this is P by 13 meter per second square. Okay, that's the instantaneous acceleration of the car. Now, that's part 2, and there's the part B. On the section of the road inclined at sine inverse 0.08, the resistance to the motion of the car is 1000 plus 20 v. When the speed of the car is v meter per second, the car travels downward along this road at constant speed. So, while the engine is working at power of 11.5 kilowatt. So while moving downward, the forces are forward driving force downward. There is component of weight in this side alpha, and alpha is 0.08, and there is resistance. So it's moving downward, acceleration 0. So d plus mg sin alpha equal to r. D is 11,500 by v, and g is 13,000 sin alpha 0.08 equal to r is 1,000 plus 20v. So we have 11,500, 13,000, and 2.08. That's 1040 v, 1000 v plus 20 v square. So 20 v square minus 40 v minus 1150. So that's a quadratic equation. Solve it to find the value of it. If you want to simplify it, you can divide both sides by 20, all the numbers by 20. So we have v square minus 2v minus 575. So 27 and 25. You can do the millisecond break, or we can apply the formula. Minus 2 plus minus square root of minus 2 square 4 into 1 into minus 575 is 5 2 into 1. So it will be 25 and minus 27. It cannot be negative, is positive, so V is 25. That's the speed. Okay, that part B. Is there any further part to this? No, let's move on to the next question. Next question is question number 7, where we have variable acceleration. A particle moves in a straight line starting from point O before coming to instantaneous rate at point X. At time t second after leaving O, velocity of the particle is. Now, these are the, where k is a constant, it is given that there is no instantaneous change in velocity at t equal to 8. Find the distance OX. Okay, since there is no instantaneous change in velocity at t equal to 8, so you can find the velocity at t equal to 8 using this equation and this equation as well. So from these two equations, we'll get two value of v, and both of them are equal. So equate them. So v8 from the first equation is equal to v8 from the second equation. v8 from the first equation, 30.6 minus 0.9 into 8 equal to 1600 by 8 square plus 8. So 8k equal to that, and this is k Okay, equal to minus 1.6. Okay, equal to minus 0.2. Now we have we have to find the distance way. Now remember, is there any possibility of velocity being negative? No, because only from this equation velocity could be negative, but for this one to for velocity to become negative. Since the value of t is 2 to 8 at t equal to 8, velocity is still positive. So there is no way that velocity becomes negative. So throughout the motion until it reaches point A, the particle is moving forward. So to find the distance OX, we have to find the total distance. For that, 0 to 8, integrate velocity, then 2 to 8, integrate that equation of velocity, then 8 to 8 to how long? 8 to how long? We don't know the value of t here. Let's say it's t1. This is the value of t when the particle comes to rest. So this value is greater than 8 here. So apply v as 1600 by t square minus 0.2 t equal to 0. So we have 1600 by 0.2 equal to t cube, t equal to 20, I guess that's this 20. Now, integrate 0 to 2, Ox is 0 to 2. Integrate the first equation 7.2 t square dt. Then 2 to 8, we have 30.6 minus 0.9 t. And finally, 8 to 20, we have 1600 to the power minus 2 minus 0.2 t. 7.2 t cubed by 3. Then 30.60 minus 0.9 t squared by 2. Limit here to 8. Here we have my 1600 t to the power minus 1 by minus 1 minus 0.2 t squared by 2. 8. Limit 8 to 20. So the first one, 2.4 t cubed. Second one, 30.60 minus 0.45 t squared. The third one, minus 1600 by t minus 0.1 t squared. 8 to 8. Now if you substitute 2.4 into 2 cubed minus 2.4 into 0, then 30.6 into 8.45 into 8 squared minus 30.6 into 2, 0.45 into 2 squared. There we have minus 1600 by 20 minus 0.1 into 20 squared minus 1600 by 8 minus 0.1 into 8 squared. And you add all these three, you get the total distance equal to 262.2 meters. Okay, so that's the third question number 7. That's it. Next, move on to, is there any further word? No, that's the end of the question. So this is it, guys. If you like the video, please don't forget to like the video, put a like, subscribe to the channel. See you in the next video. Until then, Allah Hafiz. Assalamu alaikum. Yeah.